March 4th. I teach a course called Physics 412, Precision Measurement. 12 students this semester, most of them quiet, diligent types who chose timekeeping research because it rewards patience over brilliance. I like them. I like the work. There is something deeply satisfying about measuring the universe at its most fundamental level and finding it consistent, reliable. Time does what time does, and our job is to count it more carefully than anyone else. Today, one of our cesium fountain clocks drifted. I should explain what that means. A cesium atomic clock measures the resonant frequency of cesium-133 atoms. 9,192,631,770 oscillations per second, which is how we define a second. These clocks don't drift. That's the point of them. They're accurate to 1 second in 300 million years. When your GPS tells you to turn left in 200 feet, it's because atomic clocks on satellites are keeping time precisely enough to triangulate your position from the speed of light. If the clocks drifted, your car would think it was in the ocean. So when I say the clock drifted, I mean something that shouldn't happen, happened. The discrepancy was small, 0.7 nanoseconds over the day. I recalibrated, ran diagnostics, checked the environmental controls. Everything was nominal. By evening, the drift had returned. Same direction, same magnitude. I mentioned it to David Ferrance in the department lounge. He suggested a power fluctuation, which is what I would have suggested too. I went home and didn't think about it much. My wife, Claire, asked how my day was. I said, one of the clocks was wrong. She said, so fix it. I said I did. She said, then what's the problem? A nanosecond is a billionth of a second. It's nothing. It's nothing. March 7th. It's not nothing. I spent 3 days eliminating variables. Temperature is controlled to within 0.01 degrees. The vibration isolation platform is functioning perfectly. There's no electromagnetic interference. I checked the building's electrical systems, the nearby cell tower, even the elevator motor. Everything is clean. Then I called Renata Yoon at NIST. She runs the F2 cesium fountain, which is the US primary frequency standard, the clock that all other American clocks synchronize to. I asked her, as casually as I could manage, whether they'd noticed any anomalous drift in the past week. She was quiet for a long time. Then she said, "How did you know?" Their clocks are drifting too. Same direction, same rate, or close to it. She'd been assuming it was an internal issue. They've been recalibrating continuously for 4 days. If NIST is drifting and my lab is drifting in the same direction at the same rate, independently, the problem isn't the clocks. The problem is what the clocks are measuring. Time is moving differently than it should be. I don't know what that means, but I felt something I haven't felt since graduate school. That quiet electric hum in the chest when you realize you might be looking at something no one has seen before. March 12th. I've barely slept this week, and I don't care. This is the most extraordinary data I've ever seen. I reached out to every contact I have. Kenji Ota in Tokyo, Lena Brauer in Braunschweig, Christophe Marteau at the Bureau of Weights and Measures in Paris. I emailed the GPS Operations Center at Shriva. I contacted 3 radio astronomy groups that maintain independent hydrogen maser clocks. Everyone responded within 48 hours. Everyone had noticed something. Time is accelerating, globally. At every measurement station on Earth, atomic clocks are running slightly fast relative to their expected frequency. The cesium atoms are oscillating at a rate that is measurably, barely, but measurably, higher than 9,192,631,770 cycles per second. But here's what makes this extraordinary. The acceleration isn't uniform. Tokyo is drifting at 1.1 nanoseconds per day. London is at 0.9. My lab in Chicago is at 0.8. Braunschweig is at 0.7. The rate varies by location. And there is no known mechanism, not gravity, not velocity, not any force in the standard model that would cause time to accelerate at different rates across different geographic locations on the same planet, at the same altitude, under the same gravitational conditions. This is new. Christophe, who has been measuring time at the Bureau in Paris for 30 years and has the demeanor of a man who has never once been surprised by a clock, called me at midnight his time. He said, "Julian, I have been doing this longer than anyone alive. I have never not known what a clock was telling me." There was a pause, and then he said, quieter, "I don't like this." I told Claire over dinner. I tried to explain the significance, that time itself was behaving in a way no one had ever observed. She listened carefully. She always listens carefully. Then she said, "Should I be worried?" I said no. I said it was fascinating. I feel like I'm standing at the edge of a new physics. March 17th. I haven't written in 5 days. I need to put this down carefully because I want a record of when I understood. We collected data from 47 stations across 23 countries. I plotted every measurement on a global map, color-coded by drift rate. I spent 3 days trying to find the variable that explained the geographic variation: latitude, altitude, proximity to tectonic plate boundaries, geomagnetic field strength, solar exposure. Nothing correlated. My graduate student, Priya Chandrasekaran, was in the lab on the 4th night. She was working on her own project and glanced at my screen. She said, "That looks like a population map." I told her it wasn't a population map. It was a drift rate map. She said, "I know, but it looks like one." I pulled up a global population density overlay from the UN database and put it next to my data. The correlation coefficient was 0.94. Time is accelerating fastest in the most densely populated areas on Earth: Tokyo, Delhi, Shanghai, Sao Paulo, Lagos, New York. The highest drift rates. The Atacama Desert, Central Siberia, the Australian outback. Barely any drift at all. I checked the data 4 times. I had Priya check it independently. Then I sat in my office for 2 hours without moving. Physics doesn't care where humans live. Gravity doesn't know what a city is. This isn't natural. Something is doing this. And it's doing it to us. I went home that night, and Claire could tell something had changed. She asked again if she should be worried. This time, I didn't say no. I said I didn't know yet. She sat with that for a while. Then she made tea and sat next to me on the couch, and we didn't talk. That's one of the things I love about her. She knows when not talking is the more important thing. March 20th. I published a preprint on Archive 3 days ago. The title was measured and deliberately understated. Anomalous temporal drift correlating with anthropogenic population density, a preliminary report. I thought the data would speak for itself. Some of it landed. Kenji called within hours, his voice tight with controlled excitement. Lena is replicating with optical lattice clocks in Braunschweig, which are even more precise than cesium fountains. 3 research groups I've never spoken to have emailed asking for raw data. A real scientific response is forming. But most of the world shrugged. A journalist from New Scientist ran a piece with the headline, "Has time gone wonky?" I did a 4-minute segment on cable news where the anchor asked if this meant he'd have more time to finish his novel. Everyone laughed. I laughed too, because what else can you do when someone makes a joke about the end of the world and doesn't know it? Meanwhile, the drift is accelerating. When I first noticed it on March 4th, my lab measured 0.7 nanoseconds per day. Today, it's 4.2 nanoseconds per day. A 6-fold increase in 16 days. The curve is exponential. I modeled the trajectory. If the rate holds, and it has been perfectly consistent so far, the drift will cross from nanoseconds into microseconds within 2 months. Milliseconds by late summer. By winter, a clock in Manhattan will disagree with a clock in the Adirondacks by full seconds every hour. That's when systems start failing. GPS, financial markets, power grids, air traffic control. Everything synchronized to atomic time breaks. And after the infrastructure, biology. Cellular processes, protein folding, neural signaling. They evolved in a universe where time was constant. What happens to a human body when a second stops meaning what it used to mean? Nobody knows. It's never happened before. I tried to explain the exponential to Claire last night. I drew the curve on a napkin. Flat, flat, flat. Then the elbow, then the line going vertical. She stared at it. She said, "Where are we on this line?" I pointed to a spot just before the elbow. She said, "How long before it goes up?" I said, "Months, maybe less." She folded the napkin carefully and put it in her pocket. I don't know why, but she kept it. March 25th. I haven't slept properly in days. I've been going through historical data, GPS satellite drift logs from the 1990s, NIST calibration records going back further. The precision drops off with older instruments, but I wrote software to extract signal from decades of archival noise. It took 4 days of coding and testing. The drift has been present for much longer than any of us realized. It was just extraordinarily faint. Picoseconds per day, far below the noise floor of older instruments. It's been there, growing, decade after decade. Invisible. Patient. I traced the curve backward. I found the inflection point. The moment the drift transitioned from zero to non-zero. The exact start. 1974. I stared at the number. I pulled up a timeline of significant events in 1974. I scrolled past Watergate, past the Turkish invasion of Cyprus, past the discovery of Lucy. November 16th, 1974. The Arecibo message. The most powerful intentional radio broadcast ever aimed at the stars. A 3-minute transmission from the Arecibo Observatory in Puerto Rico, directed at the globular cluster M13. A message encoding our number system, our atomic elements, the structure of DNA, the shape of a human being, and the location of our planet. A shout into the dark, a declaration that we exist. Radio waves travel at the speed of light. In 50 years, that signal has covered 50 light years. Whatever heard us was within that radius. Cosmically, that's not across the galaxy. That's next door. I sat with that for a long time. I think I already knew what it meant before I let myself say it. We spoke, and something answered. Not with a message, with a mechanism. It arrived, or it activated, or it turned its attention toward us, and it began to drain. Time is not speeding up. That's what I got wrong. Time is being consumed. What I've been measuring isn't acceleration, it's depletion. Something is feeding on the time around concentrations of conscious life, and it's been doing it since the moment we told the universe we were here. I called Lena. I told her what I'd found. She was quiet for a long time. Then she said something in German. I think it was a prayer. I've known Lena for 15 years. I didn't know she was religious. March 29th. 4 days since the Arecibo connection. I've spent them running numbers. The numbers are the only thing that still makes sense. I'll put them down and leave them. I've modeled the drain rate going forward. The exponential curve is clean, elegant even. Here is what it says. Within 18 months, time in major population centers will be moving fast enough to disrupt cellular biology. It won't feel different. That's the cruelest part. You can't feel time being drained because your thoughts, your nerve impulses, your perception, it all moves with the local flow. You'll feel normal. You'll age decades in what the rest of the universe experiences as months. Within 3 years, a day in any major city will correspond to weeks of normal time. The people will still be there, living what feel like normal lives, growing old in fast forward, unaware. Within 5 years, centuries will pass in population centers for every year that passes in empty space. Civilizations' worth of time consumed. I sent my data to every institution, every government, every news organization I could reach. I attached the model, the historical data, the Arecibo correlation. I wrote urgent in the subject line, which I have never done in 22 years of professional correspondence. Lena called from Braunschweig. Her voice was flat and careful, like someone carrying something fragile across a room. Kenji has confirmed the exponential curve independently. There are meetings being scheduled, panels being assembled. The machinery of human response is beginning to turn. It's not fast enough. I don't know what fast enough would even mean. You can't fight something you can't see, can't detect, can't describe. You can only measure what it's taking from you. I keep thinking about what time actually is. We treat it like a backdrop, a stage where physics performs. But what if it's not a stage? What if it's a substance, a finite, consumable medium? What if the reason the universe has a temporal direction, the reason time moves forward and not backward, is that something is using it, the way fire uses oxygen? And what if certain configurations of matter, complex, conscious, signaling matter, burn brighter than others? I sat with those questions for a long time tonight. Then Claire came in and asked if we should leave Chicago, move somewhere remote. I pulled up my data and showed her the map, the rural areas where the drift is weakest. She said, "Montana? Alaska? How far do we have to go?" I told her I didn't know if it would matter. The drain is accelerating everywhere. Remote areas buy time, literally, but the curve swallows everything eventually. She nodded. Then she asked how long we'd have if we stayed. I showed her the model. She was quiet for a long time. Then she said, "I'd rather be here then, with our life." I didn't argue. I don't think she's wrong. April 2nd. I left a stopwatch running in my office this morning. I carried a second one to the cafe on Woodlawn Avenue, 4 blocks away. The cafe sits on a quieter block, fewer apartments, fewer people per square foot. I drank my coffee slowly. When I walked back and compared the two, the one that had stayed in my office, surrounded by denser population, had gained 3 minutes. 3 minutes of difference over a coffee. Last month, it took atomic clocks to see it. Last week, it took high-precision GPS receivers. This morning, I measured it with a $20 stopwatch and a cup of coffee. That's how fast the exponential is climbing. I looked up one more thing. I've been assuming that the signal had to travel to whatever responded. 50 years, 50 light years. But I was making an assumption that the thing came from somewhere else. What if it didn't? What if it was already here, dormant, patient, not 50 light years away, but right here, in our neighborhood of space, silent and still? The Arecibo signal didn't summon it from across the cosmos. It woke something up, something that was already close enough to hear a 3-minute whisper. And if one was here, sleeping near us, waiting for exactly that kind of signal, the electromagnetic announcement of a species sophisticated enough to be worth feeding on, then there's no reason to think ours was the only one. They could be everywhere. One for every star system that might, eventually, produce something loud enough to be interesting. The universe is full of silence. I used to think that silence was emptiness, the vast, indifferent quiet of a cosmos too large to care. I don't think that anymore. I think the silence is patience. I went outside tonight and looked at the stars. They looked the same as they always have, bright and distant and beautiful. Claire came out and stood next to me. She didn't ask what I was looking at. She already knew. I have to stop writing, not because I've run out of things to say, but because the clock on my desk and the clock on my wall are no longer telling the same time, and the difference is growing while I watch. I don't know how long this journal will be accurate. I don't know how long I have before how long stops meaning what it used to mean. If you're reading this, whoever you are, whenever you are, I hope your clocks still agree. End of journal. The notebook was recovered from Dr. Marsh's office at the University of Chicago on April 14th. Dr. Marsh has not been seen since April 3rd. His wife Claire was not at their home. The front door was unlocked. Their kitchen table held 2 clocks, side by side. They disagreed by 47 minutes.